This is the next set of exercises on PySpark, and here we are going to deal with grouping. Let's start with simple grouping count. Let's calculate count and distinct count. So we basically group by certain order, count how many orders exist per eval set. Eval set are three sections of orders existing in this data set. They are prior test train. So we do group by, we do count, we do distinct count, and this is the result. Eval set, count of orders, count of distinct orders. Basically, orders and distinct orders are the same. This is how order prior look like. There is order ID, product ID, add to cart order, reordered. Nothing special. So we have number of rows and number of orders. Okay. Compute total and distinct products purchased in prior orders. Some distinct. So that's not the... Okay, nothing wrong here. The exercise mentions some and some distinct. However, these are not the correct functions. We need to compute total and distinct products. So we are counting products and we are count distincting products, and this is done by global aggregation. So we need to group by without any fields and count distinct. Exercise number 3. Calculate average, mean, max order number per user. So this is a simple exercise. We take some user and we do these aggregations on its order number. So average is 6, mean is the same as average, mean 0, max 9. So 6 is in the middle. So for each user we calculate this value. Not very sensible exercise, just to demonstrate aggregate function. Okay, calculate standard deviation of add to cart order per product. Standard deviation and standard deviation pop. There is a slight difference. I will show what says the difference between the two. Okay, this is standard deviation, what is called StdDev, and it's calculated per this formula. The sum is divided by n minus 1. So we divide by number of samples minus 1. And StdDev pop, here we divide by n. Therefore, the result is slightly different. So the explanation is this. This is more reliable standard deviation, as they say. Okay, as we can see, there is a difference, but it starts somewhere at the 4th digit. Yet there is some. Okay, the same for variance. We calculate variance of reordered flag. It's again not very simple. Again, in one variance and variance sum is the same thing, and variance pop is different in the same way. Here we divide by n minus 1, here we divide by n. Okay, next thing. Here is an illustration based on some fake or sample data for this variance. So you can see 1 and we have 1, 1, 0, 1. And yes, this is the data. And here variance, sample, variance, pop. So pop is divided by n, and variance is divided by n minus 1. Thus we see the results are different. Where the value is the same, all the way the variance is 0. So variance is how much the value difference left and right. So this is the formula for sample variance, and this is the formula for population variance. And n minus 1, n is the difference. When we are using show, we can use option called vertical, and it's going to display this way in the vertical format. Skewness and kurtosis. Again, two functions, pretty well statistical functions. We can check out help on them, but here we simply run them on some field. This is the explanation of this function. Skewness, measure of asymmetry. Skew means asymmetric, turned to a certain side. Positive skew, long right tail. Okay, many small values to extreme. Negative skew is left tail. Okay. Y-skews method, rather kurtosis, measure of tailedness of peak. So kurtosis means how much the data is close to a peak. It's fourth power, and it looks like this. Okay, we can heavy tail means positive kurtosis, and here it's light tail, flatter curve. Anyway, these are the functions, and we can calculate them. Okay, the next thing is correlation between two values, order day, week, and order hour. Do they correlate? And here is some correlation value. Covariance and covariance pop. Covariance is how similar is the change on two graphs. So we can calculate covariance between two values, and it's again the same thing, divided by n minus 1 or divided by n, and here are the values. This is some kind of test on test data for covariance, and so to demonstrate that the difference might be pretty significant on small amounts. Okay, per department statistic, count, AVG order rate, count and AVG. Okay, simple. We do join with products on order prior, on departments, group by department, count of products, and average. I didn't even add aliases. Okay, per aisle min max product ID, and StdDev of product ID use min max StdDev. Not much sensible exercise. Min max product ID StdDev sample. Okay, I will continue aggregation functions in the next exercise, in the next video, where the dataset is more sensible for demonstrating aggregations.